Okay, a sample of a radioactive substance has a decay constant of that, lambda equals 0.00133. I guess we could actually write that in scientific notation as 1.3 by 10 to the minus 3. And the unit is becquerel. It's disintegrations per second, but it's named after Henri Becquerel, who, along with the Curies, discovered radioactivity. So 1.3 by 10 to the minus 3 becquerel. So we want to calculate its half-life, and we have an equation that says T half, the half-life, equals the natural log of 2. Let me try that again. Natural log of 2 over lambda, the decay constant. So the natural log of 2 is there because we're halving something. So it's a power of 2 law, and it's just a number, 0.693, divided by our half-life, 1.33 by 10 to the minus 3. And it ends up equaling 520 seconds. So that's the half-life. We could express that as 8 minutes 40 seconds. So it's just under 9 minutes is one half-life. So half the amount is going to be gone after that period of time. So, all right, so if we start with a particular number of atoms, we've started with 8.7 by 10 to the 20 at t equals 0. Now 8.7 by 10 to the 20 sounds like a lot, but remember that Avogadro's number is 6.02 by 10 to the 23. So 1 mole of a substance is 10 to the 23. So this is 1,000th of a mole. That's the order of amount that we're talking about. So quite a small sample, really. On the order of milligrams, I guess. So how many would I expect to have after 20 minutes? So I start with, we've got the equation that says number of particles at time t is number of particles at time 0 times e to the minus lambda t. So in this case, number at 0 was 8.7 by 10 to the 20. E to the minus 1.33 by 10 to the minus 3 times the time. Now we should work in seconds, which is the SI unit, so 1200 seconds for the 20 minutes. Now, what do we expect? We expect that 20 minutes is just over 2 half-lives. So it will halve after 8 minutes 40, and then it will halve again. So we expect that the amount after 20 minutes should be somewhere on the order of quarter of the original amount, just very roughly. That's what we expect, a little bit under quarter of the original amount. So if we calculate that out, we find that in fact we end up with 1.76 by 10 to the 20 atoms, if we just do that calculation. So our units is atoms, because that's how many we had. That's what we had at the start. N at time t. So we went from 8 and a bit to about 2. So around 8 to around 2, and yeah, it's what we expected. It's about a quarter, a little less than a quarter of what we started with, after a little more than 2 half-lives. So that makes sense.